Hey guys, Stereo Police. So I'm back on this Fisher CA-800 upgrade. The last video I made, I told you I had some major problems with this. Now, mind you, I replaced the power supply, the main power supply, ripple filter, and storage capacitors. I replaced the power cord. Not exactly happy with the cord I have. I might put another one in there, but I just wanted a higher amperage capacity, just a less of a resistance. And I replaced the only op amp in the signal, really, when using a line level input, with a Burr Brown op amp. And that was a real pain in the rear, or a pain in the front faceplate, honestly. And I also wanted to bypass the speaker selector switch and go directly from the circuit board. And I have the binding post now, but I wanted to go directly from the circuit board to the binding post for the least possible resistive path. And I don't need a speaker selector. I never use them. I use the binding posts as my selector. Anyway, I listened to it for a while. I wasn't that thrilled with how it sounded, actually, how it sounded. Something seemed off. And also in the back of my mind, if you want to go back and watch one of the previous vids, in the back of my mind, the signal looked good, but when I turned up the treble and I viewed a 1 kilohertz signal, I think it was, I forget, maybe it was 5K, I forget, but when I viewed it on the scope, that beautiful sine wave started to, it didn't clip, it started to distort in what appeared to be a very strange crossover distortion. All right, just to remind you of the issues that I had when I first installed the Burr Brown op amp, the new old stock op amp. Let me show you. I was playing around with bass and treble controls, and this is where I was at. We were at 11.7 kilohertz. You're looking at both channels here. Hit and play. Let's start with treble going down. Here we're turning the treble dial down.
Just about nothing. Okay, treble is midway. Let's
midway
turn the treble up.
And then look at that. We started to turn the treble up.
That's weird.
So at some point, we have this positive half cycle. When we get down to the negative half cycle, we have what appears to be some sort of clipping, and it could be the current limiting device inside the Burr Brown op amp, and I'll show you that in a little bit. Okay, and this is when I'm starting to turn the treble up, and the feedback circuitry is, the treble, the tone control circuitry is in the feedback loop of the op amp. Okay, now I'm starting to turn it up, and I'm going to turn it up more. I'm going to hit play. And then we reach a point where we have that clipping, and we go into what appears to be Class B operation. Not even Class AB, but Class B. We have what appears to be crossover distortion. Some kind of crossover distortion there. I'll continue to hit play.
Get auto set on that.
And you can see both channels. It's the same thing with both channels, and you have an uneven positive half cycle and negative half cycle. They're not symmetrical, and then you have what appears to be classic crossover distortion.
I don't know what's happening there.
All right. And the way the tone controls work here is the tone controls, it's a very traditional circuit. It's actually a circuitry named after a person, and I forget it right now. Forget the name of the person, but it's a very traditional, well, this is a variation of a traditional style of bass and treble controls, and this is built in to the feedback loop of the op amp, of the Burr Brown. And I don't have my computer here, so I can't show you, but it's very understandable. It's not hard to understand. But so I got to thinking about that, and my theory is somehow it was overloading the op amp. And let me come back to that in a minute. So after I had listened to this receiver, integrated amplifier, that is, on my main system, I brought it back in here to try to explore more what was happening with that crossover distortion. Hooked it back up to my dummy loads, oscilloscope, and immediately, and these dummy loads are wire wound resistors, so they're highly inductive, as well as resistive, but they have a lot of inductance. And immediately this amp went into oscillation. It became unstable, and that instability created on the output an 80 hertz square wave, something that would destroy speakers, and was a full power square wave. It was to the rails, and my little dummy loads were heating up quickly, starting to burn the insulation off the wires. There was a little smoke there, so I had to immediately turn it off. But I did get a snapshot on the scope, and I explored it, and the thing went into oscillation, and I turned it on and off a couple times. In fact, it was pegging the meters, so I had to clip the meter wires right here. I clipped them so it wouldn't peg the meters, and I was just dismayed. I mean, why the hell is that happening? So I just had to put this project down for a while and give it some thought. And I gave it some thought, and the only possible explanation for that is the op amp. And it's not that the Burr Brown op amp isn't good, but I went back and looked at the specifications of it. And compared to the previous op amp that came out, and I forget the number designation, I've actually purchased a new one, and I have it here. The Burr Brown op amp, I had some of those. I bought more than one. Let's see if I can show you. Get my flashlight here. Now, I have one of a couple of explanations for this. There's the Burr Brown op amp right there. Right there. It's the one that I put in. And it is an incredibly good audio op amp. Let me get my readers on. Let me see if I can. It's been like weeks since I've done this, so no, those aren't my readers. Let me read you the number on that. Okay, the Burr Brown. Oh, it's so small. It's an OPA 2134. It's an incredibly good low distortion audio grade op amp. But one thing it doesn't have going for it is the ability to sync and source a lot of current. From my memory, doing research, it can only sync and source about 32 to 35 milliamps, whereas the op amp that came out of it could sync and source like 125 milliamps. And this Burr Brown right there has built-in current limiting. Built-in current limiting. So when it reaches that point, it will turn off and on or start to limit the current of that op amp. So I suspect that's kind of what was going on with that distortion. And given that all that the tone controls are in the feedback loop, and this is also a voltage amplifier, it's got a probably a pretty heavy load on it. And so I don't think this Burr Brown is spec'd out enough to handle this design, honestly. And at some point along the way, this op amp might have even gotten harmed by too much current. I'm not sure. And that's theory number one. Or theory number two, these are new old stock, because Burr Brown was purchased by Texas Instruments. So the new ones are made by TI. And these are new old stock, and maybe they're just defective. Maybe because I got them off of eBay. So maybe I just bought a defective batch of op amps. So it's one of the two things, and I'm not going to fire this amp up again and have it go into full oscillation until I make an attempt to correct this problem. So I'm going to have to replace this op amp once again. I'm not going to give up yet. I hope that my theory works and it's true. And I'll show you on, when I'm up at my computer, maybe I'll show you on paper. All right. So here is the OPA 2134, which is the Burr Brown op amp right here, 2134, that I installed, and the one that became unstable. And I had to study this for a while to try to figure out what was going on, and there's a lot of specs and ratings here, but the one of interest, I want to point this out, bring it to your attention. Got to scroll down quite a bit to get to it. Is right here. Output current is limited by internal circuitry, and here it is. We got the op amp, then we have this extra circuitry here. So its output is limited to approximately 36 milliamps. That's sourcing and sinking. That means providing 36 milliamps to upstream circuitry and sinking it from the circuitry itself. And so it's got some sort of compensation, some sort of feedback where it will limit the current. And I think that's what was going on, and at some point this circuitry was the cause of the instability. Okay, so here's the op amp. Here is the op amp that came out of it, out of the Fisher CA-800. It's the 4558, and it's a very good op amp. And I bought a new one made by Texas Instruments. And as you can see, very good harmonic distortion, 0.0001%, and the rest of these, a gain bandwidth product, 4 megahertz. It's a general purpose op amp. Has, you know, I checked the voltage supply range to see that it fits. Everything works fine, and let me point this out to you right here. Output current, plus and minus, sourcing and sinking, 125 milliamps, up from the 32 or whatever it was, 36 milliamps. So, you know, this is like tripling the amount of current. And I don't see where there's any limiting circuitry in this op amp. There's no compensation circuitry that could possibly become unstable. It's just an op amp, and there it is. A very typical op amp type of schematic. You know, starting out with differential amplifiers and so on and so forth. So there's none of that circuitry that could become unstable. Now let's go back to the Burr. We're still looking. We're still looking at the 4558. This is what I ended up putting back in, but a brand new one from TI. The one, okay, 0.0001%. Let's go to the Burr Brown that I put in there. 0.00008%. So, look, ultra low distortion, yeah, but we're already so low that it doesn't matter. There'll be more distortion introduced by the other circuitry surrounding it that it really doesn't matter. And the supply voltage range actually is less on the Burr Brown than it is on the 4558. So the 4558 is actually, look, supply voltage 10 to 30 volts. So this is actually a more durable op amp, the 4558. And again, I really believe, and I'm going to sum it up with this, I really believe that the instability, we're back to the Burr Brown here, and I mean it was unstable. It was caused by this circuitry right here, this compensation circuitry. So I have purchased another Texas Instrument audio grade op amp that can handle the full 125 sourcing and sinking milliamps that the old op amp that came out of this could handle. And the new op amp I have does not have that built-in current limiting device that may be the reason that this amp is going into oscillation. That's my only theory. The reason this amp is becoming unstable. Now, it didn't become unstable driving speakers. It only became unstable driving my dummy loads. I've already tested the resistance of these today. They're still very good and valid. Each one is 8.3, one's 8.3, one's 8.2 ohms. They haven't been shorted. Nothing's wrong with the dummy loads. So I'm going to have to desolder that plate again. I am not going to remove this entire front faceplate once again. That's ridiculous. I'm going to have to try to do all this with everything in place, because I'm not going to undertake that endeavor once again. So I'm going to have to start with desoldering that globule right there and try to move this. Even if I have to break this thing to get it away, I don't care at this point. That's an EMI shield. We'll see, but gosh, I am just not doing what I did before. Too much work. So we're going to start with desoldering that to remove this plate so I can get to the top of the op amp, and once again, here we go again, replace it. And when I get to my computer, I'll tell you what I'm replacing it with, and I'll show you the specs. All right. So yeah, I was really dismayed when this thing when this became unstable. It started to oscillate. And I just can't, that's the only explanation I have. That's why I had to put this down for a few weeks. Whenever you get frustrated with something, you just have to put it down, calm down, and come back to it when you're ready. You know, that's just how you deal with frustration. All right. Let's see if we can get this going. a lot of solder on there. Okay. I don't know, if what I'm doing now is going to work. This is my only hope. It's my only theory. All right, not bad. Oh, I'm just looking for one of my cleaning pans. Jeez. These crappy cleaning pens. Okay. Pretty nice. Now, if I could just hold this back long enough to get to that op amp, which right there. I need a new tip on my soldering iron. I'll see if I can get to it from this angle. It'd be nice if these were out of the way. Maybe a couple of them. Alright. I gotta change the tip on the iron and we'll start desoldering the burr brown. Not enough heat. I don't have a good place to rest my hands, so I'm a little shaky. Kind of working in a shadow too. Okay, I got couple clean ones. I like to make them nice and clean just by poking that iron in there, and then once it gets hot, give it a little rubby. A little rub-a-dub-dub. A little worried about that one. Okay, got 4 of them done. 4 out of the 8. This backside's a little more challenging. Maybe. At least I can see better. Pretty good. See if I can push it through. Yep, pushing it through. Pushed it through. Clean up those pads a little better. Nice. Nice. Okay. Doing a continuity test between each hole. Make sure there's no shorts. Nothing. I'll turn this over. And the Burr Brown is partially, where is it? See, it's partially popped out. Wiggle it right out. There it is. Well, sorry, old friend. I don't think you were up to the job. I'm going to mash those leads like that to indicate that it is possibly defective. All right. Let me go get the new one. Okay. Here's the old op amp. There's the one that came out of it originally, and I purchased, I can't find it, there it is, the new one. It's not the Burr Brown, but it's a TI, Texas Instruments. Perfectly up to the task. Audio op amp, very, very low distortion, low noise. I'm wearing my wristband. So first we got to get this in there. And I think I'll have to put the camber down for that. Moved it, well, maybe let's see if I can show you how to get these in. They require a little finagling sometimes. Okay. So sometimes you just gotta bend these leads a little bit in, like that. There's a little mark for pin 1. Well, got it right in. It's a little loose, it probably won't stay. So if I go on the back side and just try to bend the leads a little outward, just a little bit, it'll hold it in. All right, that's not going anywhere. Okay. And if this doesn't work, I don't know how much more time I want to invest in this, honestly. Just trying to set up the camera here. My camcorder died, so I'm using my phone. My camcorder just absolutely died. And I liked it because, you know, everyone thinks that phones are the end all and be all, but camcorders have optical zooms. And I prefer good optics when I'm filming. Good optical zoom. One. Pretty good. Oh. Always hold my breath when I do that. There's that little pond right there that I made. All right. Let's bring that back down. The lights back in. We got to solder that EMI shield. Oh, I got the wrong tip for that, but I'll just make do with it. More heat. Give it a second to heat up. Low heat. Okay. Like a professional. Like a pro, man. Always want to be professional. Mm-hmm. Okay. Now the question is it gonna remain unstable? Well, let's get it hooked up. All right. Moment of truth. I actually have a fire extinguisher ready. Now, I'm not being dramatic either. These things happen. Amp is plugged in. Dummy loads are hooked up. I've got the oscilloscope hooked up right now to the input signal from an audio generator right there. and we're inputting to auxiliary 500 millivolts at, we're going to start with 11K. 11 kilohertz, because I want to start, if this works, I want to start manipulating the treble control to see if we have the same problems we did last time with the weird, I keep wanting to say clipping, but it wasn't clipping. It was crossover distortion. Okay, volume is down. We've selected auxiliary. Click, the relay's on. Okay, let's do an auto set. Okay, nothing. Start turning the, let me check my heat here. They're not heating up. We're not oscillating. I just turned the volume up some. Did an auto set. Oh my, nice clean. The yellow is the output signal off of the left channel. Nice. Let's start with the balance control. I'm going to turn it to the left. Watch the yellow. Down to nothing. Turn the balance to the middle. Balance all the way up. So balance is working. We have a nice clean 756 millivolts output. Let's bring that output up to about a watt. We need about 3 volts. 2.6 volts, that's good. So now we got running about a watt. Nice and clean. So the blue is the input signal. The yellow is the output. Okay, we're running about a watt on the output. I'm just touching, that's the left. Let me touch the right side to make sure it's not heating up. It's not. Good. All right. That is a beautifully clean signal. Now let's manipulate the treble control. Right now we're at flat. The meters are not hooked up right now. I disconnected them. Now watch as I turn the treble to the right. You're going to see the yellow go up in amplitude, and I'm going to turn it all the way up. See, we're off the screen now. Let me do an auto set. Oh, sweet. No distortion. This is with the Burr Brown. I might have gotten a defective op amp. That's with the Burr Brown, if you remember, right here with the treble all the way up, I experienced crossover distortion and uneven positive and negative peaks. And there's nothing is oscillating here. Nothing is unstable. I had a bad friggin' op amp. So putting these Texas Instruments op amps in here, and I'll show you the spec sheet on them. They're really good. Putting these these TIs in there. See, you run the risk of buying new old stock. Let's turn the treble down. Okay, that's flat. Let's do an auto set. Okay, that's flat. Now let's turn the treble down. Watch the yellow. Down, as far as it goes. Okay, let's do a bass check. I'm going to turn the volume down. And let's bring the signal generator to 10 times 10, 100 hertz. 100 hertz. Let's do an auto set. Okay, we are at 117 hertz on the input. Let's start cranking the output up a little bit and do an auto set. All right, sweet. Let me bring that voltage up to about 1 watt. 2.8 volts on the yellow. Looking good. All right. Oh, I'm thrilled, man. I thought, wow, what a relief. Now let's turn the bass down. Watch, I want to turn the bass counterclockwise down. Watch the yellow. Down. We're back to neutral. I'm going to start turning it up. That's as far as it goes. Let's do an auto set. We're at 100 hertz. Sweet. Nice. Nice. Now let's go to about 1K. 100 times 10 is 1K. Okay. We're at 1.185K. We bring the power up a little bit to get us about 3.2 volts RMS on the output. We're not heating up. We're very, very stable. Now this is really good news. Let me turn off channel 1. Okay, now we're looking at the output. Let me see if I remember. It's been a long time. Do the FFT again. There we go. Trying to spread it out a little bit. I'll be able to show you the 1K right now. There we go. That's what I wanted. Okay, there's the 1K. So we're doing a Fourier transform. Now I'm going to turn the volume all the way down. And as soon as I turn the volume up, you'll see the 1K frequency start. There it is. There's the 1K. Right there. And there are no other harmonics right now. That's a lot of noise down there. Until I start to really crank it. Now I'm cranking it way, way up. Oh my, we're harmonically clean. Very, very low distortion. Oh, that is so sweet. I'll do that one more time. Volume's all the way down. I turn the volume up. There's the 1K popping up right there. Volume down, volume up. There's the 1K. Now let me bounce back over to auto set. And there's our 1K in yellow. Very clean. No other harmonics showing up. Sweet. Very, very, very nice. We had an op amp problem. And let me show you clipping. We all love clipping. Clipping is fun. Because clipping does tell you something about the character of the amp. And let me turn this down. Okay, we're looking at the output. I'm going to briefly, because my dummy loads can't handle the 100 watts. So I'm going to briefly crank it up. Now watch. Oops, I don't have the scale right. Okay, we'll crank it up. Ready? I still don't have the scale right. Okay, here we go. Clipping, look at that. Look at that clipping right there. It starts at the same time, and we're at 30, starts at 37 volts. And it's symmetrical, highly symmetrical. So it starts at 37, roughly 38 volts. Man, that's 180 watts. That can't be. It's V squared over R. Let me go back. Bring it right down before clipping. 30. Oh, okay. I was wrong. Right down before clipping is 34 volts. Okay. So it's 34 times 34 divided by 8. 144 watts of clean power. Wow. Now I'm going to go ahead and check the other channel. Let me turn this off. I'm leaving the input signal on there. I just want to check the left channel. There's the left channel. Clipping, same place. And there's our auto set. There's the left channel. Left channel looks beautiful. There's nothing wrong with this amp right now. The next thing I'm going to do is get the meters hooked back up and give it another test. Well, I'd love to listen to it now, because when I listened to it before, we were listening to a bad op amp. Wow, these results are fantastic. I couldn't be happier. I really couldn't be happier. Going through all this trouble and not knowing I installed a bad op amp. I'm going to go upstairs before I conclude this. I'm going to show you what I think happened, and there's a cautionary tale here about just substituting parts. And I guess I failed to heed the cautionary tale. But we'll get to that in a minute. Okay, there's still more to do here, but I'm really happy because I love the sound of this thing. And now looking at the output signal and how clean it is, at least at 1K, no harmonic distortion is showing up in the fast Fourier transform, and there's no distortion at all in the tone controls. So that was an early indicator last time that there was a problem with the op amp. All right, I'll show you a couple things on paper before we wrap this up, and then there's more to come on this Fisher. So these are the days having success like this, and even having success in resoldering that op amp without taking the faceplate off, just out of sheer frustration. It was really, really good to do. All right, thanks guys. I'll be back in a second.